Hello students, so here we are with the question 3rd of the exercise 3.1 of the chapter pair of linear equations in two variables. So the question 3rd is the cost of 2 kg of apples and 1 kg of grapes on a day was found to be rupees 160. After a month, the cost of 4 kg of apples and 2 kg of grapes is rupees 300. Represent the situation algebraically and geometrically. So if we read this question again, so the data being provided in this question is that 2 kg of apples and 1 kg of grapes which was bought on any of the day, which is not specific in this question, was found to be rupees 160. And after a month, if a person buy 4 kg of apples and 2 kg of grapes, it cost him rupees 300. So represent the situation algebraically and geometrically. In order to solve this question, we will let rupees X be price of 1 kg of apples and rupees Y be price of 1 kg of grapes. Now, if we read the statement 1, it's been given that 2 kg of apples and 1 kg of grapes cost rupees 160. So, the 2 kg apple cost can be obtained by multiplying 2 with the price of 1 kg of apples, that is 2x, and also 1 kg of grapes cost rupees y. So 2x plus y is equals to 160. So let this mark statement 1. And now the second statement says that after a month the cost of 4 kg of apples and 2 kg of grapes is rupees 300, means 4x plus 2y is equals to 300. Now simplifying this statement and taking the common factor out, that is 2 in this case, we will be left with 2x plus y, and 300 can be written as 2 into 150. So cancelling the 2 on both the sides, we will obtain 2x plus y is equals to 150. Let this statement be marked second statement. So clearly we have been able to achieve the two linear equations from this situation being provided in the question, that is we can have represented the situation algebraically, as these two equations are algebra only, as it involves only the constant and variables, right? So what the next step is to represent the situation geometrically, means we need to represent the situation, or we need to represent the equations being obtained from this question over the graph. That's what geometrically representation means. So if we write the two equations being obtained again, so the first equation was 2x plus y is equals to 160, and the second equation was 2x. Let me mark this statement with some other color so as to distinguish between the two colors. So the second equation was 2x plus y is equals to 150. These were the two equations being obtained earlier. So if we want to represent this equation first over the graph, what we need to do is to draw a table between the variables x and y and find the points which will be marked in the graph, and we will be joining those points to draw a line which will represent the first linear equation. So let us do what we are saying here, that is first step is to draw a table between the variables x and y. So drawing the table between the variables x and y, we will let the value of x. So we will let first the value of x to be 50. You can take any value of x. There is no restriction over taking the value of x. So now put this value of x in first equation, the value of the y comes out to be 60. Now again let the value of x. Suppose we have taken the value of x to be 70. So the value of the y comes out to be 20. by putting the value of x in first equation. Now, if we took a look over the graph, we see that we have been obtained the points 0, 1, 2, 3, 4 only, and if we take again the look over the table, then we have to mark the points 50 and 60, which is very high than the marks being on the graph. So in order to mark the points of the table over the graph, what we need to do is to scale the graph with the value 10. Scaling the graph with the value 10 means that each point will now be representing the point by multiplying that point value with 10. That is, 1 when multiplied with a 10 will give the number 10, means this point will be taken as point 10 of the table. This will be 20, this will be 60, this will be minus 50, and this will be minus 60, and so on. So, means the point 50 and 60 of the table will be marked as a point 5, 6 on the graph. So, marking the point 5, 6, that is this point, and the point 70, 20 of the table will be marked as a point 7, 2 on the graph. That is this point. So now in order to represent the linear equation, what we need to do next is to draw the line which will be passing from these 2 points of the table. So drawing the line, it will be looking somewhat like this. And now what the next step is to draw the table for the second linear equation. So drawing the table between x and y for the second linear equation, here again suppose the value of the x is equals to 50. Now putting the value of x in second linear equation, the value of y comes out to be 50. And now again, if we let the value of the x to be 60, then putting this value in second equation, the value of y comes out to be 30. And as we know, the graph has been scaled with 10. So 50, 50 means 5, 5 over the graph, and 60, 30 means 6, 3 over the graph. So marking these points, that is 5, 5, which is this point, and 6, 3, which is this point. So now what the next step is to draw a line which will be passing from these 2 points of the table. So we will be drawing the line. So as it is clear from the graph that these 2 lines, that is the lines being represented by the 2 linear equation being found from the quotient situation, are parallel to each other. Why these lines are parallel to each other? Because the angle made by the 2 lines are equal, and if 2 lines make equal angle means their slope is equal. So 2 lines having the equal slope are always the parallel lines which are inclined to the x-axis in this case. So this is about the geometrical representation of the situation. So means we have achieved in representing the situation algebraically as well as geometrically, that is over the graph. So this was all about the question 3rd of the exercise 3.1. I hope this question is clear to all of you.